Hi, Mark Sarazouni here from howtotunepianos.com. I'm just going to record some octaves here and measure them using my inharmonicity flowchart to see what kind of size we have. Before we get into the video, we should go through the procedures for setting check notes and for orally measuring the inharmonicity for the purpose of tuning clean mid-range octaves and for determining optimum temperament sequences. This is the procedure for setting the check notes. First, determine what the check note is going to be by going 2 octaves and a major third below the coincidental partial. Whenever we play an interval note, there will be a coincident partial, a partial that belongs to both partial series above each note. And to get the check note, you just go 2 octaves and a major third below that coincident partial. The next step, set the check note flat from the reference note so that it makes beats with the reference note of around 4 to 5 beats per second. Not too slow, not too fast. The procedure for using a double string unison, which is what I'll be using in this video, what I do is I make a double string unison by muting one string of a trichord. You don't have to do this if you're using bichords because they're already a double string unison. And then I tune the other 2 strings of the double string unison clean. Then, from that clean double string unison, I will judge its pitch. If it's not good and needs to be moved, I will move one of the strings in the direction I want to go by the amount that I think is appropriate. One of the many benefits of double string unison is you can move the note by the amount needed because you can hear how much you've moved the note by how much the double string unison is out of tune. After I move the one string the amount I want to go, I bring the other string back to being a clean double string unison. Then I'll judge the pitch again. If it sounds good, I just remove the mute and tune the third string so that the trichord is clean. And then when that's done, move on to the next note. The procedure for tuning the A3, A4, and the F3, F4 octaves is shown here. I won't go through it step by step, but if you need to, you can always come back to this part of the video and check it out. Okay, I'm going to use double string unison only because it's the most accurate way of hearing different changes. And we'll start with a really flat A3, and we'll use the A4 where it is as a reference. So we're going to try and make a clean octave from the A4. First step, you got to clean up that double string unison. That's 2 strings. For this part in the procedure, the double string doesn't have to be absolutely rock solid, pure, dead on, because the beat speeds are going to be riding on the out of tune unison. But when we get finished the octave, then it has to be clean. So now we do the 4-2. So the first thing with the check note is we always set the check note relative to the reference note. Making it about 4 or 5 beats per second. That's about okay. Now this is really narrow, so we're going to raise it. This is pretty close, and the octave sounds pretty close, so that means I was worried that this major third might be narrow, but it isn't. So the procedure is to make these 2 equal, and they seem to be equal. And then the procedure says check the 6-3. Now the 6-3 test note usually produces very fast beats, and then what I'll do is I'll change the 6-3 check note so that it slows everything down. But I already did that with this, so that's why they're slow. That might be wide. That top one sounds like it might be a little bit wider. So I know that this is a small scale piano where the 4-2 and the 6-3 can be tuned as pure. So if the 6-3 is wide, then the 4-2 must be wide too. But probably not as much because they aren't exactly right on. And so I'll go back to the 4-2 and I'm just going to re-listen with the idea that Maybe the first time it was wide, but I didn't hear it. Yes, it is wide. So now I'm going to bring up the A3, and this is where double string unison is very powerful. Whoops, too much. You hear that? That is not a lot. Now tune it out with the other pin. Now both of those sound the same to me. That means it's a pure 4/2, pure 6/3. And now when we play the octave, it doesn't sound clean. But it's not because the size is wrong, it's because one of the unisons is not clean. And the A3 because the A4 is a single string with no false beats. So here's where we get really finicky about the unison. Now that we have clean unisons, and there's a little something in the octave, we can go back. It's wide. And that sounds wide too. So we're going to bring it up. But we're dealing with some very, very precise measurements here, so we have to use the double string unison. To bring this pitch up by the smallest amount possible. And there you go, a clean octave tuned as a pure 4/2, pure 6/3. Well, what about other kinds of octaves? What about octaves that can't be tuned as pure 4/2, pure 6/3? For that, we're going to simulate that by using I'm going to try and use a C sharp. That's going to be a little tricky for me, but I'm going to try my best to make this C sharp into an A and keep remembering that it's an A. Now some pianos have this kind of inharmonicity, badly scaled pianos. Now there's some bleeding from the third string. So I'm just going to get that one. There, how's that? That's pretty good. So now that A, when we play with an F, is way off. We play it with this A. And here's an example of beat matching. I can hear la 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 at the 4/2, and this is really fat. And I can hear it sharp, so I'm thinking this is pretty narrow. It's a narrow 4/2. By how much? by that much. So I'm going to lower the A3, the quasi A3, by that much. How? Double string unison. Now there's lots of beats being produced, but I'm only listening to this one because I'm changing it so it's going to be flattened by the same amount that the octave was narrow. So I have to listen at that partial. And I got pretty close. Top is faster. That's pure-ish. Pretty pure. And now the procedure says, after tuning a pure 4-2, measure the 6-3. Well, this is narrow. So the procedure says, if it's narrow, tune it as a wide 4-2, narrow 6-3. So I'll lower the A3, quasi A3. And I've got a wide 4-2 and a narrow 6-3. The top is faster. The top is slower. So this should sound okay, but it doesn't. And that's because the 4-2 is too wide and the 6-3 is too narrow to sound good together. We've got this beating 4-2 and this beating 6-3, and they're beating really fast, and that's because the inharmonicity of this octave is so poor. So the procedure says that once you have a wide 4-2, narrow 6-3 that doesn't sound good, you tune it back to a pure 4-2. So I'll raise the A3, the quasi A3. This is a narrow 4-2 because the top is slower. So I'll lower the A3. Now it's wide because the top is faster. Just a hair narrow, maybe. And when you play it, it sounds better, certainly here. And then it's got this crazy fast beating 6-3 because the 6-3 is so narrow. But the octave ultimately sounds better than it did before as a wide 4-2, narrow 6-3. We call this a large scale octave and a large scale inharmonicity for the piano, which has nothing to do with the size of the piano itself. It has to do with the relative sizes of these partials, of the octaves at these different partials. So that's a large scale. What about a medium scale? Well, what if I was to take the B? Train coming through. What if I was to take the... Oh, I've done this already. That's why that B sounds like an A. I did it in another class. So let's check this quasi A, whose inharmonicity is a little bit closer to the actual A. And we'll do that by going through the procedure, checking the 4-2. If anything, that sounds like it might be slightly wide. Let's check the 6-3. Okay. The check note is always set relative to the reference note, eh? So that's really fast, and that's slow. So this is a narrow 6-3. And a narrow 4-2. So let's lower that A3 quasi. It's actually a B. Oh, slightly wide. Slightly narrow. It could have motion in it. Let's check the unison. There it is. There's that motion. There you go. Medium scale octave tuned as a wide 4-2 narrow 6-3. Small scale octave tuned as a pure 4-2 pure 6-3. Small scale octaves can't be tuned as a wide 4-2 narrow 6-3. They can only be tuned as a pure 4-2 pure 6-3 or wide 4-2 wide 6-3 or narrow 4-2 narrow 6-3. So there's your small scale, there's your medium scale, and there's your large scale. They all sound pretty good, but they're all different sizes. This is a pure 4-2 pure 6-3. This is a wide 4-2 narrow 6-3. This is a pure 4-2 very narrow 6-3. What I've shown you is a procedure, a very simple procedure that you can follow to tune the octaves the best size. And I've used a double string unison to do that, and I've even been using my slow pull kind of move and massage technique up here as well. So there's so many benefits in doing it this way, so many benefits. I cannot go into all of them. The ability to tune clean unisons and forcing you to have to tune clean unisons, the having to retune a unison every time you move the note gets you really good at unisons. Now, some people just understand inherently. When they see me do this stuff, they understand inherently the power of this method. Other people, not so much. But if you think, if you're watching me do this, if you're saying to yourself, this is amazing, then contact me and we can talk more about this. So I hope you enjoyed that. Here we got the small scale, pure 4-2, pure 4-2, pure 6-3, because they're pure, as far as I can tell, because I'm using these tests, which may or may not be, they may or may not be pure, but they sound pure to me. So that's why I say it's a pure 4-2, pure 6-3. And then we have the narrow What's ringing here? Something's ringing. I think it's a damper or something on the bass string. So we have the, and then we have this one, which is a wide 4-2, narrow 6-3. But not really wide. Not really narrow. This one here can't be tuned as a wide 4-2, narrow 6-3 because it would be really wide and really narrow and sound bad. So it's tuned as a pure 4-2 and a very narrow 6-3. We call that a large scale octave. Small, medium, large.